All right, so that gets us to section 2.2, which is on atomic number and mass number. Now, to do this, I'm going to revisit, I still have my drawing up here from section 2.1. I'm going to revisit this. Notice that, again, I'll remind you that in this drawing, we have 6 protons and 6 neutrons. And we established that this particular atom has a mass of 12 AMUs. All right. Now, it turns out that this number of protons is significant. So to talk about that, we are going to go back to the periodic table. Okay. Now, if we look up here, we have this number in the top left corner, or sometimes top center corner, exact or top center space of each box for each element on the periodic table. Okay. This is called the atomic number. Now, the atomic number tells us the number of protons. That's one and the same, the atomic number and the number of protons. Right? And so by extension of that, the number of protons gives us the identity of the element. Right? So the example I gave, we have an element that has 6 protons. Element with 6 protons, or an atom with 6 protons, is carbon. It can be nothing more, it can be nothing less. Carbon always has 6 protons. Vanadium always has 23 protons. I could pick any random element off the periodic table, and that is going to have, if I pick chlorine, it's going to have every chlorine atom in the universe has 17 protons. If it doesn't have 17, it's not chlorine. Right? But when we talk about atoms, we also talk about their mass. Now, if we revisit this, we talked about this particular atom, which we know now that this is a carbon atom. We know that this particular atom has a mass of 12 AMUs. Okay, this is called the mass number. Now, we find the mass number by adding the number of protons and the number of neutrons. Okay. Now, the number of protons, of course, we can find on the periodic table. We always know that carbon has 6 protons. Right? But the number of neutrons is a little bit less obvious. By the way, though, this particular element I can write, or this particular atom, I can write as carbon-12. That means it's carbon with a mass number of 12. Now, if we look at our periodic table, let me pull that back up. If we look at our periodic table again, you'll see that if we look at carbon, in the bottom, or at the bottom here, I have this number that's really close to 12, but it's not exactly 12. It's 12.011. Okay, there's some significance to that. And that leads into the concept of isotopes, which is in what section 2.3 in it essentially in its entirety is about. But sometimes, though, that can lead us, at least for the most common form of a given element. If we look at that number, we look at what it's close to, that's probably going to lead us to the most common isotope. Or I'm sorry, I shouldn't say isotope, the most common mass number that we would find for that atom. But that can also be a little bit sneaky. Just for example, and there again, I will revisit this example when we talk about isotopes in section 2.3, but for bromine, just as an example, you might look at this and think, oh, the mass number for bromine, for the most common bromine, is going to be 80. That's actually not correct. It's either 79 or 81. So anyway, kind of keep that thought in the back of your head, though. And let's revisit this. How can we find our number of neutrons if we don't know it? Okay. Well, the only way that you can actually find that is you have to be provided a mass number. Okay. So if I gave you chlorine 35, can look at the periodic table. I'm not going to pull it back up, but if you were to look at a periodic table, you would find that chlorine has a mass number of 17. I'm sorry, not a mass number, that it has an atomic number of 17. That's our number of protons. Okay, remember, that's one and the same. So if I know that the mass number of chlorine is 35, and I know that it has 17 protons, I can take 35 minus 17, and that's going to tell me the number of neutrons present. So 35 minus 17, of course, is 18, if my brain is working correctly. So chlorine 35 has 18 neutrons. But again, that's not something that you could find unless you were given all of this information. With that said, that is an exam question that I would ask you, could ask you, and would ask you. I could say, if you have chlorine 35, how many neutrons are in it? Okay. Or I could say that you have an atom of chlorine that has 17 protons and 18 neutrons, and I could ask you to tell me what the mass number of it is. Right? We could go either way. But that's how we get our mass number, though. Right, and that's essentially section 2.2 in a nutshell.